Let's see a little bit further on the pressure gauge. You can see that since F is equal to Kx and P is equal to F over A, we can combine these two expressions to get P is equal to the K over A of X. Here, X is a compression of the spring. Okay, this is X. It's a compression of the spring. Here, when the fluid exerts force to the spring, is compressed the spring by the amount of X. So you can see that the pressure is a linear. It's a linear function of X. So you can define the linear scale like a ruler on the pressure gauge. And if you look at the pressure gauge, when you measure the pressure of the tire of your car, you can see the scale, the linear scale on the pressure gauge. And this is because we have this relation when we use the pressure gauge to measure the pressure. Okay. Now we move to the topic of the variation of pressure with depth. As I said before, that the pressure in the fluid depends on the position we measure the pressure. And now in this section we will show you how to express the variation of the pressure. Here what we have to do is that assume that we place in this figure we look at the like a water or the fluid in a container. Okay. Anyway, we look at the portion of the liquid, this portion of the fluid here. Okay, and of course it is also the same fluid in this portion, but we will assume that this portion of the fluid is an object. Okay, is an object, and we want to measure the force that exerts on this object by the fluid. Okay, the force that exerts on this object by the fluid. Okay, you can see that we have the vertical force and the horizontal force, but from the symmetry you can see that the horizontal force in this direction and in this direction we cancel. It means that the force in the horizontal direction have the same magnitude but opposite direction. So it's cancel. It means that we will look at the pressure from the force in the vertical direction only here. There are two forces from the fluid that act on our object. Okay, our object is this portion of the fluid. The force on the top, this force, okay, and if we say that at this position the pressure is P0, okay, the pressure is P0, so the force here, if I say that this is the F1, we can see that F1 is equal to the P0A, and also the fluid also exert the force at the bottom. Okay, and if we assume that the pressure here is P, okay, and from the shape of the object of our object, which is rectangular, so we can see that we have the F2 here. If the force here is the F2, we have the F2 is equal to the PA, and since the shape of the object is rectangular, we have this A and this A are equal. Okay, anyway, if our object is the fluid itself, we know that in the static case, the fluid not move, which means that these objects not move also, right? So if this object is not moved, it means that the total force on this object must be equal to 0, and you can see that it is not the force, only the force from the fluid that exerts on this object, but we also have the gravitational force. Okay, act on the fluid also. So we have that the weight of the object is mg, okay, which equal to the low of HAG. Low is the density. This low is the density of the fluid, and h is the length of the vertical side of the object, right? So this is h, and A is the area. A is the area here. Okay, so you can see that this HA is the volume, of the object. So rho times the volume is the mass. So we have this equation. This rho HA is the mass of the object. Okay. And as we say that the net force is equal to 0, and the net force is the summation of these three forces. Okay, beware, when you sum the forces, you have to be careful about the direction. You can see that for F1, the direction is downward. Okay, for F2, the direction is upward, and for W, the direction is upward. The direction is downward. Okay, so we must have that F1 plus W minus F2 equal to 0, or we have that P0 A plus rho GHA plus minus PA equal to 0, or with simple algebra we can have that P is equal to the P0 plus rho GH. Okay, this can be done by you cancel A, and A here, and you get this relation. This is very important. It tells you that the pressure increase with the depth in the liquid or in the fluid. It means that if you start from this point with the pressure of P0 and you go down deep in the fluid to this point at the height H, below the original point, H below the original point, and you can calculate the pressure here from this formula. So this formula gives you the variation of the pressure with the depth H, and this is related to the not related, but if you have to know also the pressure of the reference point here, P0. Okay, so this is a variation of pressure with depth.